number 12 ni. Okay, nak determine the vertical and horizontal asymptote. First, you need to find domain. Domain. Okay, domain first for all domain, and check the interval which is defined or we call domain. And then find vertical asymptote. Vertical asymptote exists when x is not in the domain. Exclude. When x is a real number, domain real numbers, we can conclude that no vertical asymptote. Jadi mana yang tak masuk je dalam domain, maybe consider, check, maybe akan jadi vertical asymptote. Okay. Yang I say when x real numbers, ini mana no vertical asymptote. Okay. No vertical. But maybe that one ada horizontal, maybe. So all number 12 ni same procedure. Function is x squared over x squared plus 1. Okay, to determine vertical and horizontal asymptote, we need to determine domain. Domain of f. To determine domain of f for ratio check denominator. Denominator not equal to 0. Okay, not equal to 0. This one is quadratic. Kalau let's say simplify, this one is no solution. Why no solution? Because of, let's say, if you change to graph, the graph is like this, is quadratic. The graph is my graph. Nah, sini. And then check, the graph is above x-axis. Maknanya no roots. No roots. Or something, the graph not cut the x-axis. So we can conclude no vertical asymptote. Actually, no vertical asymptote. Okay, that is okay. Continue, and then change to actually x is real numbers, or x is from negative infinity to infinity. If you change to number line, from negative infinity to infinity, so x dia ni semua. Okay, so no x excluded. So let's say you need to consider ni je, this one and this one. Maybe the two green color ini produce horizontal asymptote. Horizontal asymptote. Okay, so because of x all real numbers and no x excluded, we can conclude that no vertical asymptote. No vertical asymptote. Okay, and check. Okay, if you check using this one interval, this is just two bracket, first and second, means that 2 times only. Check. Checking. So the try checking limit x tends to negative infinity and limit x tends to positive infinity. The function is x squared over x squared plus 1. X squared over x squared plus 1. And then first thing, for limit, direct substitute. The idea is you have direct substitute. Without thinking, just substitute the value. Okay, and then substitute negative infinity squared, get negative positive infinity over positive infinity. This one you cannot conclude this is equal to 1 because we don't know how big is infinity. That is numerator on denominator. So this one we can conclude this is indeterminate form. We cannot define the exact number. Indeterminate form, nilai tak tentu. Betul ke? Ikut So this one is indeterminate form. And then check the function. Poly or poly. Okay. This is polynomial over polynomial. And check. This is tends to infinity. When poly over poly tends to infinity, you have to divide with the highest power of denominator. Okay, so this one limit x tends to negative infinity. Okay, divide with the highest power of denominator. This one is the highest power, x squared. Okay, x squared. Okay, when this one is tends to infinity. When poly over poly, x approaches value, okay, That's time you need to factorize. See the differences between the treatment. Poly or poly. This one is tends to infinity. Divide the highest power of denominator. When poly or poly, x tends to approaches a value, you need to factorize. Okay, see? Okay, you have to remember that one, recall. And then simplify 1 over 1 plus 1 over x. Then substitute 1 over infinity is equal to 0. And this one is equal to 1. Settle. For this part, the second part, okay, same procedure. First direct substitute infinity over infinity in determinate form and say, oh, this is polynomial over polynomial and x tends to infinity. So divide with the highest power of the denominator. So, okay. And then the highest power denominator is x squared. X squared. Then simplify. Then 1 over 1 plus 1 over x. Actually, can I skip this one? Yes. You just show once and then just skip. Then substitute 1 plus 1 over infinity is equal to 0, 1. Okay, settle. And then how to determine whether the asymptote exists or not. This is just clue. Clue. Actually not involve any concept. Check this is y value. This is x value. This is y value. Okay. Yeah, this one is x value, y value. And then write in coordinate. X value, y value. X value, y value. Okay, let's say in you try to write in the coordinate and check. Oh, once you get this is value y, this is infinite sign. Okay, one value, one infinite sign. Okay, we can conclude that this is y equals 1 is equal to is a horizontal asymptote. Okay, so conclusion for this function. Okay. Vertical asymptote, no vertical asymptote lah. For horizontal asymptote, when y is equal to 1. Okay, just one asymptote. Horizontal asymptote. Okay, all. Okay, settle?
Saya tak okay, Doktor.
Which one?
Yang last kali.
Yang ni, coordinate. Kat just join. This is just join je. Let's say, take this one. Ni just join je. This is x value. X kan? This is y value. Okay, so this is x coordinate y. So x is negative infinity, y 1. Okay, same like this lah. X, y. Okay, once it say you ada the asymptote infinity punya sign, 1 infinity and 1 value. Ni value ni y, right? Belongs to y. This value belongs to y. So this is y is equal to 1. If y means that consider horizontal. Always horizontal. If x, consider vertical. Okay, it's okay. Just hold dulu. Kita discuss for B. Kalau problem, nanti tanya Boleh, Hazim? Okay. Try B. B mungkin nampak sikit because of first nampak tak clear because of no vertical asymptote, right? Nanti try B. Okay. Problem nampak? Okay. This one a bit complete lah. Okay. Try yang ni dia tadi first macam tak clear sangat because nak cover all. This one try. Try concentrate and dengar betul-betul. Okay. First step, given this function, you want to determine a vertical or horizontal asymptote, right? Okay. First thing you have to find domain. Domain of f. So this is ratio, means that denominator. Okay. Denominator is not equal to 0. Therefore, x is not equal to -4. Then change the number line. -4. Okay, X domain is all numbers from negative infinity to positive infinity except negative 4. Or change this one to interval. Okay. And now you need to check. Okay, this one tends to negative infinity, positive infinity, maybe will produce horizontal asymptote. Okay, and for this one, exclude. Okay, negative 4 here maybe vertical asymptote. So you need to check first one. Okay, this one 1. Okay, this one is from left, from right, and positive infinity. 1, 2, 3, 4. 4 times. Okay, so according the bracket lah, senang. According the bracket. Kalau bracket banyak lah. Ni 4 times. So kita check. Okay, try kita all. Okay, and then limit X approaches negative 4 from left. Limit X approaches negative 4 from right. Limit X tends to negative infinity. Limit X tends to positive infinity. 1, 2, 3, 4. 1, 2, 3, 4. The function is 2x squared over x plus 4. 2x squared over x plus 4. 2x squared over x plus 4. Okay, then substitute. First step, always substitute. 2 negative 4 squared, negative 4 plus 4. Then 16, 32, 0. And then infinity. Once you get infinity, you have to narrow down. Kena check detail. Okay, this one. Negative 4 from left. So here negative 4 from left. So number line, this one negative 3, this one negative 5. So negative 4 from left is negative 4.001. Negative 4.001. Negative 4.001 is greater than 4. So it gives that negative charge, negative, or from left. 32 positive over negative. So answer is negative infinity. Kita check this one. For the second one, it's okay. I continue. Substitute. Okay. Negative 4 plus 4. So this is 32 over 0 and then infinity. And detail. Okay. Detail. Check. This one from right. Negative 4 from right. And here negative 4 from right is negative 3.999. Negative 3.99 plus 4. This one less than 4. So this one is positive. Positive. From right. This one 32 over 0 positive. Positive. Okay. And here. This one substitute directly. Infinity over infinity. Indeterminate form. And check, this one polynomial or polynomial. And x tends to negative infinity. You have to divide with the highest power of denominator. Okay. And 2x squared over x plus 4. The highest power of denominator is x. So divide by x. All. Okay. And then simplify. Limit x tends to negative infinity. 2x 1 plus 4 over x. And then substitute value. This one is infinity, right? Negative infinity. Nak confirm over 1 plus 0. Answer is confirm negative infinity. Yeah, this one. Okay, for the last one, substitute infinity over infinity. Still under indeterminate form. And then check polynomial over polynomial. And tends to infinity. Divide with the highest power of denominator. Okay, limit x tends to positive infinity. 2x over 1 plus 4x. Okay, just skip this step. Okay, skip step. Okay, just show once only. Okay, then substitute positive infinity 1 plus 0 or confirm positive infinity. Settle. And then this one just clue lah. Just a clue. This one x value, y value. X, y. X, y. X, y. Okay. So x value is negative 4, y negative infinity. Negative 4 plus y positive infinity. Negative infinity. Wait, so is negative infinity. Okay. Positive infinity. Positive infinity. Check. Wait 12D ya. Okay. Saya dapat lagi. It's okay. To continue. This one is x This one is x. X is equal to negative 4. This one infinite. One value, one infinite sign. Okay. X is equal to negative 4. This one is infinity, infinity. Infinity, infinity. No value. So this is no horizontal asymptote. No value. Okay, all means that the graph diverge, right? No infinity. Okay, so this is vertical asymptote. Okay, x is equal to negative 4. The value, right? Got value, means that this is vertical asymptote. This is no value. Then that one is actually no horizontal asymptote. And conclusion for this function, the vertical asymptote is x is equal to negative 4. And no horizontal asymptote. Done. Okay guys, graph C. Graph C is macam ni. Okay, so first let's find domain. Find domain. Domain is, this is ratio. Okay, 1 over ratio. This ratio is not equal to 0. Yang ini not equal to 0. And then this one is under square root. Under square root always more or equal 0. And intersect intersect. So domain is, or this one, x squared plus 4 more than 0. Okay, so this one included 0, not included. So intercept between this is more than 0. And here let's say the x squared plus 4 cannot be factorized. Or if you sketch the graph is above x-axis. Smiling graph. Here the graph above x-axis. No roots. No, we call 0 roots, something like that, right? So it means that all domains x with me, okay, are in the domain. All x value in the domain. So domain is x is from negative infinity to infinity. Macam ni. So because of no x excluded. Okay. Why? Because of the graph is like this. All above x-axis. Okay. And if you try to find, give that complex number, right? Okay. And then from this one, or you can change to number line, or just take this one. Okay. You need to find 1 and 2 only. 2 limit. Maybe produce horizontal asymptote. No vertical asymptote. Okay. Let's say when x all included in the domain, means that no vertical asymptote. Okay. So find this one. Limit x tends to negative infinity. Limit x tends to positive infinity. Follow the domain. And then the function is x minus 2 over square root of, or set, x squared plus 4. Okay, this one is it. Okay, x minus 2 third x squared plus 4. Okay. Then first step, always direct substitute. This one is negative infinity. Okay. And this one confirm positive infinity. So still consider indeterminate form. When indeterminate form, and check, oh, this is polynomial. Polynomial over third, or third over polynomial. Okay. So for polynomial over third, when x tends to infinity, you need to divide with the modulus x. Or for poly, divide by x. For third, divide by third x squared. And check when that one is negative, this one also, this one is should be negative. Okay? So this one poly over poly when x tends to infinity. Let's say, okay, when poly over third, poly over third, when poly over third or third over poly, if x approaches value a or 1, 2, or 3, you need to multiply with the conjugate. Okay, see the differences between the two treatment. The first, here, poly over third or third over poly, x tends to infinity, you have to divide like this. Okay, poly x third, either negative third x squared or positive third x squared. When poly over third or third over poly, x approaches value, you need to multiply with the conjugate. Okay. So let's continue. Limit x tends to negative infinity, x minus 2, x squared plus 4, and then divide poly by x, third, x squared. This one negative, so this one is negative. Okay, negative, negative. And then make sure inside here is even power. X power 2, x power 4, or even power. Okay, and simplify. Limit x tends to negative infinity, 1 minus 2 over x, and then here is, okay, bring inside x squared over x squared 1 plus 4 over x squared. Then, okay, substitute 1 minus 0, 1 plus 0. So 1 over negative third 1, 1 over 1 negative, so answer is negative 1. Settle for this part. Okay, class. Settle. Okay, this one. Class, are you still with us? Ish. Okay, continue. Okay. Then here is infinity over infinity, indeterminate form, and positive infinity, poly. For poly function term, poly divide by x. For third, divide by third x squared. This one is positive. Instead, this one is positive. Positive. Okay, continue. Limit x tends to positive infinity, x minus 2, so okay, I show you divide this one. Okay, x third x squared, positive. Okay, and this one negative. Ni positive. This one negative. Simplify. Limit x tends to positive infinity, 1 minus 2 over x, and then 1 plus 4 over x squared. Then substitute the value, 1 minus 0, and then 1 plus 0, 1 over this 1. Settle, right? And then check, this one is x value, negative infinity. This one is the y value, x value, y value. So now we can say that this is y. Y is equal to 1. Y is equal to 1. Okay. Therefore, conclusion for this function, no no vertical asymptote. Okay, no vertical asymptote. Horizontal asymptote, okay, when y is equal to -1 and y is equal to 1. Settle for number 12C. Is it 12C? Okay. Okay, 12C. Settle. Dah, any problem so far? Ada problem tak? Ada problem? Tidak.
Ada.
You on? Okay, settle. Ada problem. Okay, Nima,
Okay.
problem? Yeah.
For the domain,
Yeah.
so dia selalu all real numbers.
Yeah, for the domain. But no. It depends on the given function. If under cert, x squared plus something cannot factorize, you can consider that one is real numbers. But let's say for numbers similar, in this case, let's say if the function is like this, 3x over x squared minus 9. So x squared minus 9 can be factorized, right? So now just follow find domain, and treatment is follow the domain, the given bracket. Okay, but if this one is positive, 3x over x squared plus 9, x squared plus 9 more than 0, right? So this one cannot be factorized, x squared plus 9. That's why we conclude that no vertical asymptote. Well, because of domain is real numbers. This one according the domain, follow the domain. Okay, not always the function below under set consider real numbers. Okay, what else ada lagi tak ni? 12D. Okay. Okay, check domain. Okay, by right you have to check domain up and down. Okay, but for your level, maybe just consider down because of here, yang this one function ni real numbers. Real numbers. So consider the denominator, domain of f, and consider denominator not equal to denominator not equal to 0. Okay, and then x not equal to 3. Okay, and then change to number line. Okay, 3. Okay, the domain x is all real number except 3 ni. And if you change to interval, this is interval. Okay, interval. Then and check. And now this one tends to negative infinity to infinity. Okay, maybe this one is consider horizontal asymptote. And for this part, which not include right here, negative from left, from right, maybe vertical, produce vertical asymptote, maybe. So you need to check. Okay, for horizontal maybe. Okay, negative infinity, positive infinity. For vertical, 3 from left, 3 from right. So you need to check this one left, right. Okay, so if you given only the interval, you have to check 1, 2, 3, 4 times according the bracket. Or change to number line and check. So check 4 times to find whether that one the function has a vertical or horizontal asymptote. Okay, check. Okay, limit x approaches 3 from left, limit x approaches 3 from right, limit x tends to negative infinity, limit x tends to positive infinity. So 4 times according this one, the bracket. So the function is x squared plus 1 over x minus 3. Okay, x squared plus 1 over x minus 3. X squared plus 1 over x minus 3. X squared plus 1 over x minus 3. And the next step, first is substitute directly. Whatever it is, you have to substitute directly. Substitute the 3 squared plus 1. Ignore negative or positive sign. Just take 3. Okay. And this one, 3 minus 3. This one is 0. And then 9, so 10. 9 plus 1, 10 over 0. In this case, and then you have to narrow down. This one is just negative. Negative. We're going to check whether this 0, okay, it tends to negative or positive. Kita tahu answer this confirm infinity, infinity positive or negative. Okay, and check how to check. Check the number lines ni 3 on the left ni sini. So that one is so this one number 2, number 4. So 2.999. 2.99. Okay, substitute 2.99 kat sini kan. Sini 2.99 minus 3. Less than 3 minus 3. So yang this one less. So this one is negative just negative. Just negative. Ni 2.99. Okay, and just in your mind 2.99 minus 3. And then 0 negative. So positive, numerator positive, 10 over negative. So answer is negative infinity. Okay tak you all? So far okay?
Okay.
Okay. Kita continue. Substitute directly. 3 squared plus 1. 3 minus 3. They got 10 over 0 and infinity. And check, check. Oh, this is 3 from right. So ada problem, And then 3 from right is check or number line. 3 right is now here 3.0001. Okay, and then here is 3.001 minus 3. This one more than 3 kan? So that's positive. Answer is positive. Positive, 10 over positive. Positive. Settle. So on this one, okay, the third one, substitute directly. Substitute directly. Substitute cert ni, cert, and you get infinity. And substitute this one, denominator also infinity. Infinity over infinity. This is consider under indeterminate form. Okay, if indeterminate form, you check lagi. This is function cert over poly. So when cert over poly or poly over cert, for this one x tends to infinity, you have to divide with the absolute value of x. Okay, macam ni divide. Okay, cert divide by square root of x squared, and poly divide by x. Okay, yang ini divide by cert x squared. Okay, since this one negative, this one suppose negative lah. Follow ni. Yang this one poly divide with the x. Okay. If not sure, check. Check lecture note. Okay. And then limit. Okay. Negative infinity. And this one I bring here. Okay. Okay. X minus 3 over x. Okay. Actually, you must skip this step. Okay. And is equal to limit. And then here is 1 plus 1 over x squared. 1 minus 3 over x. You must skip this step. Yang ni. Yang ni boleh skip. Okay. Or boleh skip ini juga. It's okay lah. Continue. Okay. And substitute negative infinity. Okay. 1 plus 1 over infinity confirm 0 Okay, over 1 minus 3 over infinity 0. Okay, and then negative cert 1 over 1 is equal to negative 1. Okay, settle for this part. Okay, the second part here. Okay, and substitute infinity over infinity. Indeterminate form. And check, oh, this is cert over poly. And positive infinity means that you yang cert ni divide with the cert x squared and poly divide by x. Okay, and limit x tends to positive infinity. Okay, show juga. And then x minus 3 divide by this one. Divide by x. So this one positive, positive. So x, why? Because of this one is positive ni. Okay, check this one positive, so need positive. When that one is negative, this one also negative. Dia partner dia. 4x x squared. 4x x squared. Yang poly just divide by x. Okay, then simplify. Okay, simplify. Can I write like this? Dah write Okay, and then 1 minus 3 over x. I skip this one. Okay, then substitute the value. 1 plus 1 over infinity 0. 1 minus 0. Answer is 1. Okay, and check whether that one is consider asymptote or not. Okay, check. This is x value, y value. X value, y value. X, y value. Y, x value. Okay, and then check. Oh, x value is 3. Y is negative infinity. This one 3 and positive infinity. The coordinate. This one just actually clue. Clue to figure out that one is whether that one is asymptote or not. Okay. Negative infinity x, then y, and then positive infinity 1. So now here is value for x. Okay, value for x. So when that one is actually you get a 1 value, 1 infinity sign, this one consider vertical asymptote. Okay, this one x, this one y. So y is equal to negative 1. Okay, this one is y is equal to 1. Therefore, conclusion, vertical asymptote is x is equal to 3. This is vertical asymptote. Horizontal asymptote. Okay, you have two horizontal asymptote. Y is equal to negative 1 and y is equal to 1. So settle for number 12D. Find domain. First find domain. Domain. Okay. Everything ni kan. This one is x plus 2 square not equal 0. Okay, kan? Dia punya not equal to 0. X plus 2 not equal to 0. X not equal to negative 2. Domain. Okay. So now if you change the number line kan. Ni negative 2. So domain all real numbers except negative 2. Okay. Okay, negative ni. So transfer to interval. Tengok saya transfer. Tengok please concentrate ni. Tak tahu ni apa ni, mesti problem. Okay, ni. Because of complete, this is macam almost complete lah. Maybe lah tengok dulu tengok dulu. Okay, concept complete. Okay, but we still don't know whether this one this question has vertical or horizontal. Still no lah kan. So now sekarang to check, kita tengok ni. Yang ni the first and the last one negative infinity, positive infinity for horizontal. Check whether that one is horizontal horizontal sahaja. Okay. And yang this one this number maybe vertical asymptote. So you have to check first in 1 set limit as x tends to negative infinity. This one, x approaches negative infinity from left. So from left. This one, limit as x approaches negative infinity from right. Okay. And limit when x tends to positive infinity. Means that how many bracket you have? 1, 2, 3, 4. You have to test 4 times according the ni. Okay, follow. So maybe maximum is 6 lah kan. So kita kata try. Ni. Try buat. Okay. So limit x approaches negative 2 from left. Limit x approaches negative 2 from right. Limit x tends to negative infinity. Limit x tends to positive infinity. Follow dia punya. Okay. The function is x minus 2, x plus 2. Okay. Square. Okay. X minus 2. Okay. X plus 2. Square. Then this one x minus 2. Okay. So expand better expand lah. Easy to manage. Okay. And substitute value better expand for yang tends to infinity. Infinity better expand lah the polynomial. Okay. Ini. So now first step, whatever it is, first step direct substitute. Jangan fikir lebih. Substitute je. Direct substitute. And then direct substitute negative 2 minus 2. Apa dia? Negative 2 plus 2 square. And then negative 4 0. Okay, and then infinity. Okay. So now if I have to check tapi this one actually square. Dah confirm positif. Dia confirm positif. Tapi actually nak check juga negatif yang problem 0 kan. So this one negative 2 from negative 2 from left. Kita kan show this is negative positif, negative 2 from left. Tengok number line. Ni negative 2 from left kat sini. Ini negative 1 0 negative 3 negative 4. So kat sini negative from left kat sini. So choose take one number negative 2.001. Okay. Try substitute negative 2.001 plus 2. Negative 2.001 is more than bigger than 2. So negative ni just 0 just negative. Negative 0 just negative. Okay, to the left square positive. So this one negative. Okay, negative 4. So answer is negative infinity. Okay, you all try this one. Try this part. Direct substitute. And then negative 4 confirm that's a 0 squared confirm positive, right? And then negative infinity confirm positive. Let's say you want to check juga, check my problem 0. So negative 2 from positive. Negative 2 from negative 2 from right. Okay. So negative 2 from right kat sini. See negative 2 from right kat sini. That is negative 1.999. Kan? Ini negative 1, negative 1.999. Substitute negative 1.99. Negative 1.99 plus 2. 2 is bigger than negative 1.99. So yang ini just positive. Okay. And then square all confirm positive. Okay, so negative infinity. Settle this part. Yang ni pula. Okay. This one, this part. Substitute. Kan kita substitute directly. Substitute je lah. Confirm infinity. And then over infinity. Indeterminate form. And then indeterminate form actually poly. Over poly. And tends to negative infinity. And okay, when poly over poly tends to negative infinity, negative or positive. So you have to divide with the highest power of denominator. Denominator is ni. Okay, the highest power of denominator is 1. Okay, so compare to the other one, when poly or poly, okay, and adds a purchase value 1, 2, 3, poly over poly adds a purchase value A. Okay, you have to factorize completely. Factorize, not completely, factorize and cancel. This one poly or poly, x tends to infinity. Okay, divide with the highest power of the denominator. Okay, there are two different treatment. Okay, problem function sama, same, but a purchase or tends to different one. Yang satu pergi hujung sana, ini almost a purchase a value. So limit x, okay, this one, okay, divide the highest power denominator is x squared, divide x squared. So the answer is, not the answer, simplify before you substitute 1 over x minus 2 over x squared, and then 1 plus 2 over x plus 2 over x squared. Then substitute 1 over negative infinity is equal to 0. This one is also 0. 2 over infinity, 1 plus 0 plus 0. So the answer is 0. Okay, 0 over 1, 0 lah. 0, right? Okay. And this one also same. Okay, substitute infinity over infinity, indeterminate form, poly over polynomial, and then x tends to infinity. So we need to divide with the highest power of the denominator, x ini, and x, the highest power of the denominator is 1. Okay, x squared. So now x over x squared is 1 over x over 1 minus 2 over x squared, and then 1 plus 2 over x plus 2 over x squared. Skip skip this part. Then it's okay, just skip. Up to not sure one. And then substitute 0, 0, 1 plus 0 plus 0, and is equal to 0. Okay, and check. This one comot sikit ni x, y value, x value, y value, x value, y value, x value, y value. So this is just clue nak involve concept actually. Okay, x negative 2, negative infinity. Okay, and negative infinity 0, positive infinity 0. Ini just coordinate x, y. Ini x, y, x, y, x, y, x, y. Just refer to coordinate. Okay. Then this is x. This one x. Okay. And then y infinite sign. Okay. Means that consider asymptote lah. Okay. Ini y. This one y. This one consider x is infinite. So this is consider horizontal. So for this function, vertical asymptote is x is equal to negative 2. Okay, and horizontal asymptote is y is equal to 0. So that is the answer for 12e. Okay, fx x squared minus 9. This is x squared minus 9. Okay, if 12a, x squared plus 1, right? 1 plus x squared plus 1, this quadratic cannot be factorized. Means that x can take any net values, real numbers. Okay, means domain is real numbers for negative infinity to infinity n. Okay, then no vertical asymptote. Now, given x squared minus 9, domain x minus 9 not equal to 0. Denominator. This one denominator. Factorize. Okay, factorize. Then x not equal to negative 3 or x not equal to 3. Let's say if you, okay, can you quite no lah because of this one is not equal. And then change to number line. Number line. Okay, check. Let's say those yang blur saya check ni. Okay, here. No, this one. Okay, choose this. Okay, so domain from negative infinity to negative 3. Okay, negative 3 to 3, then to infinity. Domain. Then, so change to interval union. Okay. Then here, this one. Okay. First one, infinity, negative, positive infinity. Maybe we produce horizontal asymptote. But for the middle one, ni 1, 2, 3, 4. Maybe produce vertical asymptote. So you need to find 1, negative 3 from left, negative 3 from right, 3 from left, 3 from right, and positive infinity. 1, 2, 3, 4, 5, 6. 6 times. You kena test. So, test 6 times. Okay. Buat pelan-pelan 6 times. Okay. First case, kita try check vertical asymptote. Vertical asymptote is limit x approaches negative 3 from left, limit x approaches negative 3 from right, limit x approaches 3 left, limit x approaches 3 right. Okay, function is x square. Okay, better factorize lah. Okay, easy for you to manage dia punya value. Right, square x minus 3 x plus 3 x square. Okay, x square x minus 3 x plus 3. Okay, factorize. Okay, then start. Substitute directly. Substitute negative 3 square. Okay, negative 3 minus 3. This one negative 3 plus 3. Okay, 9. Actually, let's skip this step. Negative 6. This one 0. And 0. And then is equal to 9 over 0. And then infinity. Once get infinity and check detail kan. Negative 3 mana? Yang 0 negative 3 from left. Tengok number line negative 3 from left kat sini. This one is negative 4, negative 2. Ini sini is negative 3.001. Negative 3.001 substitute. Negative 3.001 is more than 3, so just negative. Okay, so negative 6, negative, positive. Okay, so this is positive infinity. Okay, try do this one. Substitute negative 3 squared, negative 6. This one negative 3 plus 3, and then 9 over negative 6 0, and then 9 over 0 infinity. And check problem negative 3 plus, and negative 3 on the right hand side is here negative 2.9999. Negative 2.9999 is less than 3, so negative, just negative. Negative wait, oh this one negative, this one is supposed positive. Positive lah, left side. Okay, negative 2.99, double check. Negative 2.99, just positive. This one is negative, positive, negative. So negative infinity. Negative infinity. Try this one. Substitute 3 minus 3, 3 plus 3. And then 9 over 0, 6. And then 9 over 0, infinity. This is minus group ni. So 3 negative. So 3 on the left is here. 2.999. 2.999 less than negative 3. So just negative. Negative, positive, negative. So this negative. Try this one. 3 square. 3 minus 3. 3 plus 3. And then 9 over 0. 6. And then 9 over 0. Infinity. And check. 3 on the right and 3 point problem. 3.001 more than 3, so positive. Positive, positive, positive. Answer is positive. And conclusion. Sini the conclusion is x, y, x, y, x, y, x, y. So negative 3, positive infinity. Negative 3, negative infinity. 3, negative infinity. 3, positive infinity. Okay, conclusion. This is x. This is x. Okay, x is equal to 3. X is equal to 3. So, but make sure that here is confirmed. The other side tu infinity, infinite sign. Okay, and if this one value 4 or 5, that one produce points, not asymptote, right? And then conclusion for vertical asymptote. Okay, x is equal to negative 3, then x is equal to 3. Settle for vertical asymptote. Okay, now we have other two items to test for horizontal asymptote. Horizontal asymptote, the second case is horizontal to determine the horizontal asymptote. Okay, so limit x tends to negative infinity. Limit x tends to positive infinity. Then the function is x squared over, okay, no need to factorize. Okay, just right. Okay, and then first step is direct substitute. Infinity over infinity. Indeterminate form. And polynomial over polynomial. Polynomial or polynomial for this one tends to infinity, you have to divide with the highest power of denominator. Okay, just repeat the same thing, right? Just show lah. Okay, show, divide. This is the highest power of denominator. And then simplify 1 over 1 minus 9 over x squared. Substitute 1 minus 0 is equal to 1. Okay, this one do the same procedure. Okay, and substitute infinity over infinity. Indeterminate form. Polynomial over polynomial. For x, this one need to divide with the highest power of denominator. 1 minus 9 over x squared. Okay, I skip this one. Okay, and substitute 1 minus 0. 1. Settle and check x value, y value. X value, y value. So, negative infinity 1. Positive infinity 1. So, this is y. Y is equal to 1. Y is equal to 1. So, and check, this is infinite sign. Infinite sign confirm. Okay, y is equal to 1 is a horizontal asymptote. And then conclusion for this question, vertical asymptote, negative 3 and 3. When x is equal to negative 3 and x is equal to 3, and horizontal asymptote is when y is equal to 1. Settle. Okay, sama je. Okay, sama je. Yang ini dengan sama je. Kali ini x squared, x minus 3, x plus 3 sama, akan jadi sama konsep. Okay, tapi it's okay, kita discuss number 13 lah, discuss. Okay. Tengok Okay, find domain. Domain interval where f is defined. Okay, same domain and find all asymptotes. So domain. Okay, here domain denominator x plus 1 x minus 2 not equal 0. X not equal to negative 1 or x not equal to 2. Okay, so now kita pun transfer to number 9. 1, 2. Okay, so okay, domain is from negative or all real numbers except negative 1 and 2. All. And transfer to interval. So now check here the first one tends to negative infinity and positive infinity, maybe horizontal asymptote. Okay, then first second in this one. Okay, test for vertical asymptote. So ini first. Okay, maybe this one first. Okay, and this one is negative 1 from left. Ini from left. 1, 2, and negative 1 from right. This is negative 1 from right. 2 from left. Sini left. Okay, 2 from right. Sini right. And this one the limit test. So how many? 1, 2, 3, 4, 5, 6. You need to test 6 times. 6 times. According to the bracket. 6 times. So, okay. Concentrate on. Okay. 10, 6, 4, 6. Is it too small? Okay lah. Kita try. Or just do vertical asymptote first. Case vertical asymptote. Senang. Vertical asymptote. Okay, the test limit x tends to negative infinity on the left. Limit x approaches 1 x approaches negative 1 from left. X approaches negative 1 from right. Okay. Limit x approaches 2 from left. Limit x approaches 2 from right. Okay, then this one for test vertical exist or not that. And the function is x minus 6, x plus 1, x minus 2, x minus 6, x plus 1, x minus 2, x minus 6, x plus 1, x minus 2, x minus 6, x plus 1, x minus 2. 6 times test. Okay, so substitute directly. Negative 1 minus 6, negative 1 plus 1, negative 1 minus 2, and check negative 7, 0, negative 3. And then confirm the answer is negative 7 over 0. Okay, because of 0 times negative 0. Confirm the answer is infinity. Now, we have to check in detail. Okay, check in detail. Which one produce 0. So, negative 1 from left. The rest just ignore, substitute negative 1. Okay, so negative 1 from left. Okay, negative 1 from left. Ini this one is negative 2, 0, 1, 3. Okay, this one negative 1 from left, negative 1.001. Let's say this is, kita choose one value, negative 1. 0.001. Okay, and then this one is negative 1.001 more than 1. So this is just negative. Negative times negative 3, positive. So negative 7 over 0 positive, negative. Answer is negative infinity. Okay, kita try the second one. Ini substitute. Thirdly. Okay, negative 7, 0, negative 3. So confirm negative 7 over 0 and infinity. And check, problem 0. 0 means from right. Negative 1 from right. Negative 1 from right. Ini 0 kan? So negative 0.999. Okay, so less than 1. Okay, this one less than 1 plus 1. So dia just positive. 0 to the right. So positive times negative, negative. Okay, so negative 7 over negative, so positive. Okay. Okay. Okay, continue. Okay. Okay, normal. Okay. And then substitute 2 minus 6. Okay, 2 plus 1, 2 minus 2. And then negative 4, 3, 0. Confirm negative 4 over 0, right? And infinity. And check, the problem 2 minus 2 before is x, right? So it's for negative, negative. 2 left, less than 2 sini. So 1.999 less than 2. So less than 2 minus 2 just negative. This one bigger than this, right? Negative. So 3 times negative, negative. 3 positive, times 0 negative, negative. And 4 negative 4 over negative, positive. Positive. Okay, try the fourth one. Okay, class, are you still waras? Okay. You all okay? Okay. Good students and discuss quickly. Okay. Okay, then 94 over 0, infinity. And check. 2 from right. Okay, right. So, 2 from right is here. 2.0001. Okay. 2.001 is more than 2. So, positive, just positive. 3 positive, 0 positive, positive. Negative 4, so negative. Okay, now this is okay. Time to check whether that one is form vertical asymptote not. Okay. Ini x value, y value. This one x, y. X, y, x, y. So, actually check lah. Okay, this is form infinity. So, this value consider asymptote, right? Okay, negative 1, negative infinity. Negative 1, negative infinity. Negative 1, positive infinity. You have to check, show both. Okay, 2 positive infinity, 2 negative infinity. Okay, and then so since this one is infinity, 1 infinity sign, and this one x, 1 value. Okay, x minus 1, x is equal to 2, x is equal to 2. So, this one consider vertical asymptotes are x minus x equals negative 1 and x is equal to 2. Settle for vertical asymptote. So, check, this is just vertical. We're going to test horizontal. Horizontal. Okay. Dah done for part vertical. Okay, the second case is test horizontal. Whether this function has a vertical horizontal asymptote or not. Horizontal. So, okay, horizontal. Confirm x tends to negative infinity or x to tends positive infinity. Tu je, tak lain. And then x minus 6. Okay, for horizontal, better expand. Okay, better expand. Okay, now try to manage and expand. If you do in bracket, you have to check. Okay, and then expand, and then substitute directly. Negative infinity over infinity. Indeterminate form. Poly over poly. Poly over poly. Okay, and then infinity tends to infinity. So you have to divide to the highest power of the denominator. Okay. Divide the highest power of denominator as well. And then limit x tends to negative infinity 1 over x minus 6 over x squared over 1 minus 1 over x minus 2 over x squared. Okay, and then substitute, simplify. 1 over infinity 0 minus 0, 1 minus 0 minus 0 is equal to 0. This one is equal to 0. Okay, this one also substitute, direct substitute, infinity over infinity. Indeterminate form, and check this one, polynomial over polynomial, and x tends to infinity. That means same treatment with this, divide with the highest power of denominator. Okay, so divide the highest power of denominator is this one. Okay, so now you get x over x squared, 1 over x, 6 over x squared, 1 minus 1 over x, 2 over x squared. Then factorize, substitute value, 1 over infinity, 0, 0, 1, and 0, and 0 is equal to 0. And check x, y value, x value, y value. And then this one is negative infinity 0, 0. Tak cantik ni. Kenapa dia macam ni? Tak apa. Sekejap, lama. Mana pergi dia hilang? Okay, so negative infinity 0. Cantik Positive infinity 0. Okay, one infinite sign, one value. This is belongs to y, right? Okay, this one belongs to y. Therefore, horizontal asymptote is y is equal to 0. Then combine, join all the asymptotes. Therefore, for this function, okay, asymptote, vertical asymptotes, negative 1 to right. X is equal to negative 1 and x is equal to 2. Horizontal asymptote, y is equal to 0. Okay, that's it for number 13. Number 14, function g is defined by gx equals 3x over square root of x squared minus 4. Take the intervals where g is defined. Domain, find domain. Okay, and domain of course under this one, x squared minus 4 more than 0. Okay, determine the vertical asymptotes of g. Okay, check for domain and check x which is exponent in the domain. Okay. And C is find this one is actually horizontal asymptote. When x tends to positive infinity and x tends to negative infinity, and then check whether horizontal asymptote exists or not. Okay, we will discuss number 14. So ini for domain. Okay, everything ini denominator under square root pula tu. So x squared minus 4 more than 0. Dia double Mula-mula over something. Lepas tu cert. Ni ada cert. So yang this one ini, this one not equal to 0. Yang this part ini more or equal 0, intersect lah. So tak sama kosong sama and dapat ini. Okay, and then check, oh this is quadratic factorize. Then because of quadratic factorize and okay, graph smiling face graph sini -2, 2. So the graph is positive ni, positive, mesti the graph is above y-axis ni kat ni kan. So if you transfer to number line, inilah ke sana not included. Okay, and then from negative infinity to negative 2. That's one, dia punya domain. So transfer to, taklah, merah lah pula. Wait Okay, from negative infinity to negative 2, union to infinity. Then you check. Okay, yang ini, okay, maybe horizontal asymptote. Okay, horizontal asymptote. Okay, this part, this one, maybe produce vertical asymptote. Okay, vertical asymptote. So you have to check ada how many times. 1, 2 from negative, 3 positive, and 4. Okay, so yang ini negative 2 from left je. No domain, no x on the right hand side. From 2 juga left on the left hand side tak ada domain. So tak payah check. If you check, substitute 2 from left, you akan dapat undefined. Undefined. Okay, and then you kena check. Okay, nanti you buat ataupun buat and check dia punya konsep betul tak. Okay, yang ini you kena cari limit x approaches -2 from left. Kiri je kan. Limit x approaches 2 from right. Ni ya. And limit x tends to negative infinity. Limit x tends to positive infinity. So 1, 2, 3, 4. 4 ni lah, check. Maybe on the left hand side ni produce vertical, and on the right hand side ni ni maybe horizontal asymptote. Okay, so write down dia punya function lah ni. Okay, so for this one, yang approaches ni, okay, better you factorize. Nampak senang nak manage, factorize. Nak manage. Okay, for this one yang ni tends to infinity, tak apa, ambil je. Okay, nak manage lah kan. So buatlah kerja, substitute directly and problem check. Ada masa tak you all? Okay, substitute. You all nak boleh discuss sampai habis ke macam mana? Ke nak stop? Nak buat sendiri? Nak discuss laju ke nak stop?
Bukan sampai habis.
Discuss dengan laju. Okay. Okay. So saya discuss laju Substitute. Ini negative 2. Ini negative 2 minus 2. Negative 2 plus 2. Okay, negative 6. Ni confirm, harus confirm. 0 ni 0 kan? Okay. Ini negative 4. Actually confirm akan jadi positif under square root. Tapi kalau awak lupa, baru check 0 ni. Maknanya on the left problem ni. So the number is negative 2.001, more than 2. So just negative. This one confirm positif lah. Kan negatif. So dia jadi negative infinity. Okay, kita nak laju lagi. Yang ini 3, 2. Okay, 2 minus 2, 0 problem. Okay, yang akan dapat 6 over. Okay, problem 4. The problem here, 2 on the right. 2 on the right ini. Okay, maybe 2.001 lah. Okay, more than negative 2 and more than 2, so positive. Confirm positive. Kalau negative, undefined, right? And then 6 over 0 positive and positive infinity. Okay, settle. Yang this one, ini substitute infinity over infinity. Infinity over infinity and indeterminate form. And poly over cert. And infinity ni divide dengan poly divide by x. Yang ni cert ni divide by x. So x squared, negative, right? So limit x tends to negative infinity, 3x, x squared minus 4. Yang ini divide by x, yang this one divide by negative x squared. Why negative x squared? Because of this one negative. Ni negatif, ni negatif kan? So kita pun ni limit x tends to negative infinity 3 negative 1 minus 4 over x squared, and then substitute 3 negative 1 minus 0, so negative 3. Settle. Ayo ni nak teruskan perjuangan ke? Tak apa. Yeah, this one limit x tends to negative positive infinity divide by x. This one divide by x squared. Positive and then substitute 3 over 1 minus 0, 3. So now check. This is negative 2, negative infinity, to positive infinity, negative infinity, negative 3, positive infinity, 3. So vertical asymptote x is equal to negative 2 and x is equal to 2. Horizontal asymptote y is equal to negative 3 and y is equal to 3. Done. Settle. Dah.